isolate the radical. Here's the original problem, and I notice the radical is already by himself, so I don't have to do anything. So this is 4x minus 3 equals 5. Then it says square both sides. So the square root of 4x minus 3 squared equals 5 squared. Now I'm going to get an equation which says that 4x minus 3 equals 25. Then solve for x. Add 3 to both sides. 4x equals 28. Divide both sides by 4. X equals 7. So that's the answer I got, but I'm not sure whether or not it's going to check. So is it true that the square root of 4 times 7 minus 3, is that equal to 5? Well, this is the square root of 28 minus 3, which is the square root of 25. The square root of 25 is 5, and it checks.
On the test, do you need us to show you that we check it?
No. Now, this is a situation where you notice the radical is not by itself. The radical has a plus 5. And I think what we need to do, quite honestly, change this plus to a minus, because I'm not ready to get into this yet.
Just do that.
I just changed the problem. I changed the problem because I'm not ready to get into the issue that this thing is going to bring up.
It brings up a big issue.
Brings up a big issue, yeah. So that means add 5 to both sides so that the square root of 3a minus 2 is equal to 6. Now, square both sides. In one instance, I'm squaring the radical. The other instance, I am squaring 6. So I get that 3a minus 2 equals 36. Solve for, in this case, we're solving for a. This says that 3a equals, add 2 to both sides, 38. Now I'm going to end up with a fraction because I changed the problem. So that a is going to be 38 over 3. Now you would check your answer, and it's not as bad as you think. Is it true that the square root of 3 times 38 over 3 minus 2, is that equal to 6? Well, since the denominator here is 3, the 3's reduce out from the 3 outside and 3 inside. This gives me the square root of 38 minus 2, which is the square root of 36, and the square root of 36 is 6, and it checks.